Welcome to another session in our webinar series on high-precision bearings. In this video, we'll focus on two key aspects that are critical to performance and reliability: preload and accuracy classes. Both factors have a major impact on precision, smooth operation, and service life in demanding applications. We're glad to have you with us again. Over the next few minutes, we'll provide an overview of the fundamentals of preload, its benefits, and the various ways it can be applied. We'll explore how preload affects properties such as stiffness, rotational speed, and service life. Next, we'll cover the accuracy classes of high-precision bearings, from P4 to SP and UP, and explain why these differences matter in practice. Finally, we'll look at how preload and tolerances interact and give you a preview of our next webinar series for the upcoming quarter. Preload refers to the force acting between the rolling elements and the bearing rings, even when no external load is applied. In other words, preload can be described as negative clearance. It ensures zero play in operation and enhances both precision and stability. When properly applied, preload offers several benefits: higher system rigidity, improved running accuracy, reduced noise levels, and longer service life. In addition, it prevents sliding movements, which can occur especially at high speeds or under light loads. There are several ways to generate preload in high-precision bearings. A classic method is direct preload through installation. Here, bearings are mounted so they are under a defined tension from the start. This method is very precise but requires exact matching of components and tolerances. A second widely used method is spring preload, particularly in high-speed spindles. A spring applies force to the outer ring of a bearing, which is mounted to move axially. The advantage is that the preload remains constant even when the bearing expands due to heat. However, this method is not suitable in all cases. Under changing load directions or unpredictable shock loads, its effectiveness is limited. In such situations, preload must be set precisely during the bearing's installation in the application. Preload affects the properties of a high-precision bearing in a way similar to the contact angle, which we discussed in detail in Webinar 2. As preload increases, the stiffness of the system rises, but its suitability for high rotational speeds decreases. Manufacturers typically define standard preload classes ranging from extra light to light, medium, and high. With increasing preload, both axial and radial stiffness increase, but the bearing's temperature also rises during operation. This means that both the maximum allowable speed and the calculated service life are reduced. High stiffness can therefore only be achieved at the expense of speed capability, while conversely, high speeds always involve compromises in stiffness. Excessive preload combined with very high speeds can, in extreme cases, even lead to bearing seizure. In addition to preload, the accuracy class also plays a decisive role. It indicates the precision with which a bearing has been manufactured. That is, how closely the specified dimensions are maintained during production. This is based on international standards that clearly define dimensional and running tolerances. In practice, several accuracy classes have become established. P4 is the most common tolerance class for high-precision bearings. An even tighter manufacturing tolerance is offered by P4S, a standard widely used in FAG bearings. For the highest precision requirements, Class P2 ensures extremely fine tolerances, while P2S allows for even more refined adjustments. There are also special standards such as SP, which go beyond P4, or UP, which are applied particularly to cylindrical roller bearings when maximum precision is required. It is important to note that, while accuracy classes are standardized, the designations often vary between manufacturers. Many use additional codes or their own gradations to highlight specific quality features. For this reason, it's always worth checking the manufacturer's specifications to ensure proper comparison. In addition, every bearing undergoes individual inspection by the manufacturer. The measured deviations of the inner and outer rings are documented directly on the packaging. So if you want to know exactly how precise a bearing has been manufactured, You can find this information on the product itself. In practice, preload and accuracy class must always be considered together. This also applies when pairing multiple bearings. If you'd like to learn more about this, we recommend our webinar on arrangements of high-precision angular contact bearings. Even the highest accuracy is of little use if the preload is not selected correctly. Conversely, an optimal preload offers no benefit if the bearing's accuracy class does not suit the application. Only the interplay of both factors ensures that stiffness, smooth running, service life, and speed capability are properly balanced. That's why it's especially important to consider both aspects together when designing a bearing system. This brings us to the end of our webinar on preload and accuracy classes in high-precision bearings. We've seen that preload is essential for stiffness and precision, while the accuracy class defines how tightly a bearing is manufactured. Only when both factors are combined do high-precision bearings reach their full potential. With this session, we're also concluding our entire webinar series on high-precision bearings. If you're joining us for the first time, we encourage you to watch the previous episodes as well. Very soon, we'll be starting a brand new series, this time focusing on belt drives and accessories. We'd be delighted to welcome you again then. Thank you for your attention.